Okay, I wanted to talk through a few more drawing conclusion examples and just make sure we're thinking correctly on these and kind of help guide your thinking if you're not feeling super confident with these. So I want to remind you to really pay attention to the given information and read it as a conditional statement. If angle 3 is complementary to angle 4, then what do you know for sure is true? And I'd also encourage you not to focus too much on the picture. I'm intentionally giving you pictures that are complex, trying to get us to focus on what do we know for sure is true. If you see a word in that statement, use that word and think to yourself, what is the definition of complementary? You already know what complementary angles are. Don't second guess yourself. Don't doubt yourself. The first thing that came to your head when I said the word complementary was 90 degrees. Make an equation that says that. And if you look at your definition page, you should have two angles are complementary if and only if their sum of their measures is 90 degrees. So we're using the conditional, if they're complementary, then the sum is 90 degrees. And the conclusion part is the 90 degrees. If I had told you they add up to 90 degrees, you could have made this conclusion. So remember, it works both ways. And my definition of complementary angles, here's the big idea of deductive reasoning. Definition of complementary angles says it's true for any two angles that are complementary that their sum is 90 degrees. Therefore, in this particular case, since angle 3 and angle 4 are complementary, measure angle 3 plus measure of angle 4 equals 90 degrees. Okay, most of you are okay with that one. This one was a little bit of a tricky one. So let's take a look at this. And this one's tricky, I think, because our given information is not stated in words. We just have this picture. So I'm going to ask you, what do you know is true? Okay, we've got this scenario. What do we know? And there's one thing I told you that you're allowed to assume. I told you this back in chapter 1. Only one thing you're allowed to assume the entire year. And that's if we have a straight line, something that looks like a straight line, it is a straight line. So we have two angles that are making a straight line. And we've defined those to be a linear pair. So in words, I would say our given information is angle 1 and angle 2 are a linear pair or form a linear pair. If that's true, then what conclusion can we make? And the most specific conclusion we can make is probably this. Oops. Angle 1 and angle 2, sorry, this is what I want to say. I'll get to that in a second. We can say that they're supplementary because they form a linear pair, and that we have defined as the linear pair theorem. Check your theorem page. It's on there. We proved it. Okay. That gets me from knowing, and in your head, you've already jumped to 180 degrees, but here's the deal, folks. You can't say 180 degrees. So if you try to say this, that the measure of angle 1 plus the measure of angle 2 equals 180 degrees, you have to know they're supplementary. That's the definition of supplementary, but you have to be told if they're supplementary, then their measures add up to 180 degrees, then you can say it. So if I've already stated this, then I can follow it with this, and that could be the next step in a proof by definition of supplementary angles. But that would have to be the next step. So without having that, we can't just do this as a standalone statement. We can't go straight from linear pair to 180 degrees. Here's what we could do, though. We could say measure of angle 1 plus measure of angle 2 is equal to the measure of angle ABD. Now I'm not using a specific thing. I'm not using 180 degrees. I'm just saying, hey, this angle plus this other angle adds up to the whole thing. And we're always allowed to do that because that's always true for any two angles that are adjacent and make a larger angle. And that's true by my angle addition postulate. So those would be two correct ways that you can complete this statement and reason based on that given picture. Okay, hopefully that helps with that one. I'm trying to think what else you guys said. I had a lot of equaling 180 degrees, and we're going to stay away from that because that would have to be a follow-up. Okay, so taking a look at this one, this is a complex one. I'm actually going to say that there's 4 correct things that we could say. So most specific, most of you said the first one there. If two segments are congruent to each other, I like to mark it like that, then we know D is the midpoint of AC. A lot of times we reverse it and we start with this. If D is the midpoint of AC, then you tell me this. Okay, definitions go both ways. So definition points a midpoint if and only if the segments are congruent. And I essentially say that the definition of a segment bisector is the same thing, that it produces congruent segments. Some people define a segment bisector to be a segment that divides a segment at its midpoint. And I'm just going to go with both midpoint and segment bisector definition. We can jump to them being congruent and vice versa. So that's how I'm getting this one. So both of these, really good options. One that a lot of people didn't say is if two segments are congruent, then we know their measures are equal. And we could actually say that AD is equal to, whoops, I got a typo there. Sorry about that. This should be a D. AD is equal to DC. Clean that up so we can actually read it. AD is equal to DC, just restating it with equality. That's the definition of congruent segments, says if two segments are congruent, their measures are equal. So that would be also a very direct conclusion coming from that given statement. This one at the bottom here is a great conclusion, but not as specific. So if I say specific conclusion, not the best, but we certainly do know that AD plus DC equals that whole length. Okay, and then I wanted to talk about this one over here. BD bisects angle ABC. So we have this congruence, and we want to jump to bisects. Be careful. We're not bisecting an angle. If we were bisecting an angle, we would end up with two angles being congruent to each other, and that would have had to be my congruent statement. So if I knew those two angles are congruent, then I could conclude this. Because I know the segments are congruent, not that. Sorry, we'll actually erase it. Since I don't know that, I just know the segments are congruent to each other, I'm going to stick with we're bisecting segment AC, and that's my better answer, not this one. Okay, not necessarily true that if one is true, then the other is true. I could draw a counterexample to that and draw something where I have, oops. Okay, so better if you do it in GeoGebra. But if those two segments are congruent, it really doesn't necessarily mean that angles 1 and 2 are congruent, depending on what your triangle looks like. So we'll explore that more later, but stick with anything on the right side here is good for this one. Okay, so I think this was number 4. Angle 1 is congruent to angle 2 if we have a bisector of an angle. Okay, here we go. Now we're bisecting an angle. Then now we can say angle 1 is congruent to angle 2, definition of angle bisector. Make sure you're getting the angle in there. So that's a great conclusion. And then down here, I have another possible conclusion that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle LEV. And hopefully you can agree that's true by the angle addition postulate. Hopefully you can also agree that that one's not my most specific conclusion. So there's one other more specific conclusion that I'm going to say would be better than saying that. Not that that's wrong, but not the most specific when I say specific. So I would encourage you to use your angle bisector theorem as another option here. Remember that says not that the two parts are equal. That tells me angle 1, not that it's equal to angle 2. I know that, but that's the definition of angle bisector. It tells me that each angle is half the whole. So angle 1 is equal to half of this entire angle, which is angle LEV. So those are my most specific conclusions. The third one is obviously also true, but not as specific. Okay, so we've got lots of options here. I'm not going to go through this as specifically because we've got this bisector, and we can do basically the same thing we just did in the last one. Definition of angle bisector theorem, angle addition postulate, not as specific, but also true. What I want to look at is this angle 2 is congruent to angle 3. Hopefully you're agreeing with that. How do I know that's true? Yes, of course it's because they're vertical angles, but what is it? And it's not my definition of vertical angles. So that one we have to say is our vertical angles theorem. The definition doesn't include congruence. So if you want to use the definition of vertical angles, what you're going to have to do is the definition just tells me that angles are vertical if and only if their sides form opposite rays. So by looking at the picture, I can state that angle 2 and angle 3 are vertical angles, and that's what I'm allowed to say by definition of vertical angles. If I want to go to congruence, I have to use the vertical angles theorem. This is a great conclusion. You're welcome to use that. Now that we've established it as true, just make sure you're referencing that theorem. Okay, hopefully this is helpful. Just a quick follow-up, 3 other questions that were on here. I might as well give you the answers. This one would have been ESPO. Not transitive property. Some of us missed that this is one equation leading to a second equation. If it helps you, I should have done this. Let's do this. Let's rewrite it. putting this underneath. Measure of angle A equals measure of angle C, and observe that A is still there, C is still there, B is gone. How did it disappear? We subtracted it from both sides. Second one. There's your transitive or substitution property. You have two things equal to the same thing, so 3 and 1 are both equal to 2. Therefore, they're equal to each other. That is my transitive property. And then the last one should have been symmetric property of equality. Okay, hopefully that was helpful. And hopefully you're feeling a little more confident with that stuff.